we need to talk about something that challenges how we think about aging itself. Your chronological age, the years since you were born, tells you surprisingly little about your biological age, how much your body has actually aged. Epigenetic clocks measure biological age through DNA methylation patterns, and the implications are profound. DNA methylation is a chemical modification to your DNA that doesn't change the genetic sequence but affects gene expression. As you age, specific patterns of methylation accumulate predictably across your genome. Researchers like Steve Horvath discovered that these patterns are so consistent they can predict age with remarkable accuracy. But here's what's exciting and somewhat unsettling. Your biological age, according to these clocks, can differ significantly from your chronological age. The Horvath clock, Grimm age, and phenoage each measure slightly different aspects of biological aging. Grimm age predicts mortality and health span better than chronological age. Phenoage correlates with physiological system function. These aren't just academic curiosities. They're measuring real biological aging that predicts disease risk and lifespan. Now, can you actually reverse biological age? The research here is genuinely remarkable. Several interventions have shown measurable biological age reversal in studies. A one-year trial combining diet, exercise, sleep optimization, and relaxation practices showed an average of 3 years of biological age reversal measured by the Horvath clock. That's not marginal. That's substantial, measurable change. Specific dietary patterns show promise. Diets high in plants, moderate in protein, low in refined carbohydrates, and rich in anti-inflammatory compounds correlate with younger biological age. The Mediterranean diet consistently shows up in this research. But it's not just what you eat. Caloric restriction and time-restricted eating also appear to influence epigenetic age favorably. Exercise has clear effects on biological age. Both aerobic exercise and resistance training show benefits, but consistency appears more important than intensity. People who maintain regular exercise throughout life have biological ages significantly younger than sedentary individuals of the same chronological age. The mechanisms likely involve reduced inflammation, improved mitochondrial function, and direct effects on methylation patterns. Stress management is critical here, and the data is quite strong. Chronic stress accelerates epigenetic aging measurably. Practices like meditation, yoga, and other stress reduction techniques show biological age benefits. This isn't just feeling better subjectively. It's measurable at the molecular level. Supplementation regimens that show promise include compounds affecting methylation directly or indirectly. B vitamins, particularly folate and B12, are methyl donors involved in methylation reactions. Some protocols include NMN or NR for NAD+ support, as NAD+ influences sirtuins that affect epigenetic modifications. Here's the practical challenge and a significant warning. Epigenetic testing isn't cheap, typically several $100s per test. You need baseline testing, then follow-up testing after intervention periods to see if your biological age changed. Without testing, you're intervening blind. And here's the thing. Biological age reversal doesn't necessarily mean you're aging backward in every sense. It means you've favorably altered methylation patterns associated with aging. We're still learning what this means for actual health span and lifespan. Interpretation requires nuance too. Sometimes biological age increases temporarily during interventions that are actually beneficial, like intense exercise training. Your biological age might look older during a stressful training period but younger after recovery and adaptation. The exciting prospect is that we now have molecular biomarkers of aging that respond to intervention. You're not just hoping lifestyle changes help. You can measure whether they're actually affecting your biological aging rate. That's unprecedented in the history of anti-aging medicine.